Okay, so we got to a point in the lecture notes where I said it's time to plug stuff in, and then I listed a bunch of stuff, and one of the things on the list we didn't have. The thing on the list that we didn't have is the population standard deviation. And as I said over there, typically when you're trying to estimate a population mean, you don't know the population standard deviation that goes along with it. And this is a problem because you need the population standard deviation in order to figure out the shape of your sampling distribution and in order to answer the question. The solution to this is to estimate the population standard deviation. And in this class, I'm actually not going to ask you to calculate any confidence intervals with a known population standard deviation, simply because it's just not that common a circumstance, and I mostly showed you that equation just to show you how I'm going to get to this next equation. Typically, when calculating a confidence interval, you will instead be estimating the standard error using the sample. And so we're going to be using something called the estimated standard error formula that I'll show you over on the document camera in a second. And as a quick caveat, you can use this estimated standard error formula as long as the sample is large or the variable underneath it is normally distributed. So basically, we want to make sure that we have the characteristics that you need for your sampling distribution to be normal in order to use this confidence interval formula. Otherwise, we're going to go back, we're going to have the exact same steps, the exact same formula. We're just going to be substituting the estimated standard error instead of the actual standard error. So you'll be determining that critical z-value, and then you'll be using the confidence interval formula with the estimated standard error. All right, so we're going to go right back in.